morning, ladies and gentlemen. Back to the DCD Talk stage. To all of you watching us live, if you're not immediately on the stage, don't forget your headphones because the sound won't carry. If you need more headphones, they're just behind us to the right as I'm looking at it here. And to the thousands of you watching on the live stream, thank you for joining us. This interview will also be available on demand, so thanks for tuning in. I'm delighted to say that we're joined by Marshall Sorenson, VP of Business Development for Shockey Precast. Marshall, maybe Shockey's not the biggest brand yet here at the event, but yet you've worked on hundreds of data center projects. Some people may be more familiar with Metromount, the sort of parent business. Do you want to talk a little bit about those hundreds of projects and I guess the Shockey Precast role, how you see yourselves as a business, and just set a little bit of context before we dive in?
Absolutely. Thanks very much, Dan. As you mentioned, I'm Vice President of Business Development Sales with Shockey Precast, a Metromount company. We're headquartered in South Carolina, but we operate manufacturing facilities in Georgia, the Carolinas, Florida, and two in Virginia. I represent the northern of those two plants in Virginia and Winchester, from which we've done to date 84 all-precast concrete data center shells, which is the reason I'm here today. You can't really get to blinking lights fast if you don't have a building to put the things into it. So going fast is something that we really care about. We've been in the data center business principally now since 2003, mostly in the Northern Virginia area, but other places as well. And going fast really depends on a lot of things that we've learned over the last 20 years or so. And I'm going to touch on those with the concept of left of zero and providing certainty of outcome, speed to market. But we've done a total of 21 million square feet of this stuff, so we have learned a few things over the years. Some things the hard way, some things the not hard way. But the thing that we've learned the most, Dan, I think, is attitude. You've got to have, if you're going to go fast, and you're going to provide certainty of outcome to REITs and cloud providers and general contractors, you've got to have the right attitude. And our attitude is best exemplified, I think, in a little vignette I'll tell about the Indianapolis 500. You know, most people in the U.S. are familiar with the Indy 500. It's the biggest same-day sporting event in the world. It's an auto race. It's a 500-mile auto race. And it's a good example of our attitude. There are 11 rows of 3 cars in the Indianapolis 500. And they circle the track before the race starts, not knowing exactly when the green flag is going to drop. They know it's going to drop, but they don't know exactly when. And our attitude is we're going to be on the front row and in the pole position every time. Not just with any one particular client, but to the industry as a whole, because we know that the winner of the race most of the time comes from the front. It doesn't come from the back. The people that are back a ways or at the end, they're not going to win the race. They're just not. So to be on the front row in the pole position, you've got to be nimble to the endless creativity of the REITs and the cloud providers and the general contractors. And you've got to be nimble to the constantly changing environment. You know, jobs pause and then they become unpaused and then they die. And then they come back abruptly and equipment changes. I can't tell you how many times we've done projects and equipment changed during the course of the design multiple times. And for a manufacturer, you've got to be able to handle all those things. So the idea is we're going to be on that front row in the pole position, and we're going to be able to provide certainty of outcome in a highly chaotic process, which is data center construction. And one of the, go ahead.
I'll just tease that out a little bit, right? Because you're talking about that agility and that nimbleness. And I was chairing a panel yesterday with Digital Realty and HKS Architects and a few others. And to lean on your race car analogy, we're seeing sort of traffic jams right now in terms of that supply chain, right? So talk us through, you mentioned all of those projects that you guys have worked on. Talk us through some of those lessons learned and time to market strategies, because that's the big pain point right now. Is, you know, you've got those really compressed timelines, but the supply chain's a bit unpredictable right now. How do you see that? Talk us through some of the time to market support that you can provide.
Absolutely, that's a key thing, Dan. And we've learned over the years the importance of the concept of being left of zero. It sounds trite, it sounds simple, but it's incredibly powerful. What left of zero means is that you're meaningfully engaged at the earliest stages in the life of a project. You don't come on board 2 days to showtime or 2 weeks to showtime in a shotgun marriage of a bunch of disparate people, some of which are qualifications-based selection, some are not. You have to be meaningfully left as zero. And I'll give you an example of what that means. There's something that you do better than anybody else. I don't know what that is, but I'm sure that's true. There's something that almost everybody in this room does better than anybody else. So the key is you have to get everybody's best thing. And you cannot do that when you are 2 days or 2 weeks before zero. Zero is bid day. Zero is just the day that some custodian harvests all of these computer-generated bid solicitations and tries to identify what is an apparent low price. And I can guarantee you it's not as low as it could have been if you had involved like-minded people weeks or months before that. So the idea of left of zero is we're going to involve people very, very early in the life of the project. I've been involved in projects that were 9 years in the making. Okay, that's not typical in the data center business, but you get the idea. But you want to grab everybody's best thing, and the way that we do that, to answer your question about speed to market and how do you get there, is we've created a very specific test fit proposal process. And so I'll go to an owner as an example, and I'll say, hopefully weeks, months, sometimes a year in advance, and they'll come to me. They'll say, okay, well the building's it's this long and it's this wide, and it's 48 megawatts, and here's the place on the earth it's going to go. You go figure everything else out, and that's perfect. So then we will do a test fit analysis where we will model the building based on the basis of design, the seismicity, the wind loads, the loads of the equipment, all the things that we need to, basic things we need to know. And we'll create a design, an all precast concrete design of the building. And I'll go to you and say, do some clash detection, see how this syncs up with the rest of your trades as an example. And that process is an iterative back and forth that could take several weeks, but it's very important because then it leads to a budget. And the budget leads to a schedule. And I can develop enough actionable and meaningful information for an owner to base their decision on whether our typology makes sense or not. And let's be real. It has to make sense. There's no smoke and mirrors, and the test fit policy is the best way we've come up with to reveal whether it makes sense or it doesn't. I can say, having done 84 of these projects, we didn't trick all these smart people into believing things that are not true. So the test fit has benefited us because it reveals the nature of those projects.
And that links back to your earlier point on certainty of outcome, everyone being fully aligned. And if we take your left of zero piece, those sort of rigid flows of the past where you're doing 1, 2, 3, 4, 5, because of the supply chain position, sort of moving around a bit, you're doing 1, 3, 5, 6, just to get the project done. How do you get there? How do you align? How do you deal make effectively within the constraints that we're seeing right now?
Yeah, that's a great question, and I like to cook things down to low gravy and tell easy vignettes to try to explain things. And the vignette I would say is in our system of all precast concrete construction, we may have 1,000. I'm making this up, so don't hold me to it. There may be 1,000 pieces in a 400,000 square foot multi-story data center. Let's just say. And it'll take us about 25 or 30 human beings on the job site to erect that gigantic building. Compare that to a more traditional method of construction. There may be 10 times as many pieces and hundreds of people on the job site. So what do you want to do? Do you want to give your kid who has a school project the responsibility 2 days in advance to go put this 10,000 piece puzzle together with all those people that you have to find, train, motivate, keep healthy, and keep safe? Or do you want to evolve a single point of responsibility and give them weeks or months to figure all the things out to be figured out, who have a fraction of the people, a fraction of the failure points, and it can go much, much more quickly? So the way to deal with supply chain is to do the least amount of stuff possible over the longest period of time so you can get everybody's best thing. And that's what we do. So we create a mechanism where people have the ability to do that. We don't. I often, people in my office make fun of me because I poke fun at computer generated bid solicitations. These vapid things that come in the inbox. They don't mean anything because it's too late by then. You should have had things figured out months or even years ahead of that time.
And that's really the message, again, to borrow your term, to get left of zero and get everyone aligned at that point, because anything else is too late.
Mm-hmm.
Let's come on to talk about the kit of parts, as it were.
Yes.
You're working, you talked about the sort of nearly 100 projects. You're working with hyperscalers all the way back through that ecosystem.
Mm-hmm.
What's the sort of Shockey kit of parts? How are you positioned there and differentiate?
Yeah, that's a great question.
Secret sauce on it.
Yeah, thanks for asking that. I frequently forget that we're speaking to a broader audience than ever before, and not just a bunch of Oshucks people in Northern Shenandoah Valley in Virginia. So let me begin at the beginning. So an all precast concrete data center shell means what it sounds like. The entire superstructure above the foundations consists of precast concrete components. You'll have the bones of the building, which are the columns and the beams that hold up the double T's. If anybody's parked on a parking garage, you're familiar with that typology. But you'll have double T's for the floors, double T's for the roof. You'll have shear walls for the lateral force resistance. You'll have walls for stairs and elevators. You'll even have precast stairs. So an all precast building is essentially the entire superstructure of the data center above the foundations. So that's kind of get that mind's eye first. Now, over the years, we weren't smart enough to figure this out. We had to be taught this by some of our clients who said, can you get rid of columns in our data halls? Sure, we can do that. We'll just make different columns, and we'll make beams that go farther and hold more load. It's just a matter of making the investment for different forms and shuffling things around. It's just the will to do those things. And we did it, and I said, I'll never forget, I asked, I won't say who or what the exact number was, but I'll say, what's the benefit of this to you? And the answer was, it's a gigantic number per column in the data hall. And on that particular
space saving.
Yeah. And there were 119 columns we got rid of because we spanned much further than normal, which meant we had to have deeper double T's and heavier beams and things that are different than most precasters make. Excuse me. So we radically changed our kit of parts, to use your phrase, to accommodate what we were told had a tremendous economic value. And we've made significant investment over the last 6 or 7 years in enhancing and adding to that capacity uniquely for the hyperscale data center market. And it's not an easy thing to do. It can be disruptive, which is why a lot of folks don't do it. But the kit of parts is really, really important. You want to have the fewest number of pieces that work the hardest possible so you have less stuff on site. And I can't tell you how many times that I've been told by our general contractor clients or owners, developers, how important it is to have an uncluttered site, to get in there quickly, to erect the building very fast, fewer failure points, less of everything. Particularly, I was in a discussion yesterday, and one of the panelists was lamenting the keen challenge of getting people. You got to get people. Where do you get them? There are no trades. People of my age are not, they're not going into the trades anymore. So you have to have fewer people on site. And using our typology is one way to really lever on that.
So, and you made the point earlier on, there's often equipment changes or design changes that you're being tasked with, and you just talked about the column example. How are you dealing or working with operators or builders on the future-proofing side and making sure that everyone's designing and building with 5, 10, 15 years? Because the IT tech is coming out 5 years' time, but the building needs to run for much, much longer than that. So how's that playing?
That's a really interesting and great question. I'll give you an example. I can't talk about the owner or any of the details of the project because of the nature of the owner. However, we were involved in a design build project. It was an unrestricted 2-part design build. Could have been anything. And so a lot wasn't figured out during the 2-stage process. And this particular design build team wanted the flexibility. It wasn't necessarily future-proofing, but it was the flexibility to complete the design. They didn't know exactly what their equipment loads are going to be and where the equipment was going to go and all that. Right. But they knew they needed a building to put all that stuff in, and they needed a building really, really fast, which is why we were selected. And so what we did is we did, I won't say agnostic, but we designed a framing grid that was capable of handling a pretty wide range of loads and locations of those loads. not excessive so that you were inherently killing the project's economics, but
Right.
we made it so that a reasonable range of equipment could fit within this kit of parts. And we told you what that is. You can do anything you want as long as it's not longer than this, wider than that. and they said, well, that's exactly right. Precast concrete has at times a bad rap of being inflexible. They say you can't drill anywhere you want to, you can't put a penetration anywhere you want to. And it's true, there are certain places you can't drill or penetrate, but it's not true that it's inflexible. So we create what we call no-fly zones or no-cut zones. And we say, okay, look, here's the double T, Dan. You can do anything you want in 90% of the area of this double T, but you can't do it here.
Right.
And same thing for a beam. You need a penetration for whatever. Your fire retardant system, fire sprinkler system. You can core here, but you can't core here. So we're very specific about the rules that we create for the design team early on, and we don't wait until it's too late to discover there's clashes that can't be resolved. We identify all those things early on. Now, whether that's future proofing, it's not really, but it could be applied to the idea of future proofing later.
Well, at least moving forward, they know what those rules are for each part of the structure that you're putting together.
Mm-hmm.
You said something really interesting when we were talking before around, don't let perfect be the enemy of good, and as long as you're aligning and communicating, you can get there a bit faster. Do you want to, just to close out, talk a little bit around that and that mentality and paradigm of approach?
Yeah, and I think, and I don't know whether that's a Nordic saying or not. I think it is. I'm Norwegian. Don't let the best be the enemy of the good. That's just another way of saying you can slightly over-design things to have a broader appeal to certain design impulses. I'll tell you another. I like vignettes. Another example of that kind of encapsulates everything we're talking about in the few minutes we have left is, as a precast concrete manufacturer, we use fine and coarse aggregates, which are just rocks. We use cement, we use sand, we use water, we use some basic stuff to mix it up and make these components. We could make stuff tomorrow if we had shop cards or shop drawings. Shop drawings are just the manufacturing instructions that the folks in the plant use to make the beams and the double T's and the columns. Well, where do shop drawings come from? They come from engineering. And where does engineering come from? It comes from effective design assist. And where does design assist best come about? It comes about in this left of zero crucible I call the test fit proposal. And it's not an exaggeration to me to say that the difference between effective design assist and no design assist is really the difference between everything and nothing. If you don't get everybody's best thing and you're not involved early, meaningful, and figuring all that stuff out and doing design assist, doing engineering, and leading up to shop card, you can't take advantage of the inherent ability we have to go super fast and just start making stuff. So left of zero and early gauge is just super, super critical.
And also the breaking down of those traditional silos perhaps, and working with the engineering team and putting this together, again, as early as possible.
Well, you bring up a good point. I don't know if we have time to go into it, but most schools and universities do not teach, per se, precast concrete methodology. They teach steel. A student who graduated, all three of my kids were Virginia Tech. You go to Virginia Tech, they can pull out a manual and learn how to design a steel building on themselves without involving anybody. And you really can't do that with an all-precast building. You have to involve folks like us and become engaged in that design assist effort. So there's some, and we're taking strides to improve on that and to teach more people how to do it. But that's something that we have to do, and that's another reason to have a thorough design assist effort.
Great stuff. It's been a pleasure having you with us. Are you sticking around for the rest of the day?
I am, yep.
People are looking to find you?
Absolutely. Thanks for the opportunity.
Great stuff. Thank you very much.